Okay, as promised, I was going to do some review problems for the FST section 7.4 and 7.5 quiz. And so these problems will be similar to the quiz. I hope you find them helpful. Of course, as always, come in and see me for extra explanations if need be. Okay, so the first one we're going to look at is this problem, 2 sine x equals square root of 2, and we want to find the principal values for this function. So when solving a trigonometric equation, our ideal thing is to first get the trigonometric function by itself. We want to get it isolated. So this is a quick move for this problem. I'm going to go ahead and divide both sides by 2. Divided by 2. And I get the sine of x equals the square root of 2 over 2. Now this says we want the principal values. Now remember, for both the tangent and sine functions, the principal values refer to the values between negative 90 and positive 90 degrees. Okay, cosine is different, that's between 0 and 180, but for sine and tangent it's between negative 90 and 90 degrees. So I look at my unit circle and find where sine is root 2 over 2, and that happens at 45 degrees. Okay, that's where the sine value is root 2 over 2, so x is equal to 45 degrees. Okay, so that's a quick, clean problem. The next one up we're going to look at is a little bit more complicated, same type of problem, but a little bit more complicated. This is a situation where we want to recognize some algebraic features. This one is reminiscent of a quadratic problem, and the reason why it looks like a quadratic is because of this cosine squared. Whenever you see squared as the highest degree, I want you to think quadratic. So again, this one's quadratic, so I'm going to apply the quadratic formula. To remember the quadratic formula, we have 3 numbers we have to identify. A, which in this case is 2, B, which in this case is 1, and C, which in this case is negative 1. I then plug them into the quadratic formula. Now the quadratic formula usually solves for x. It tells us what x equals. But in this case, we're not solving for x, we're solving for the cosine of x. So now I go ahead and plug things into the quadratic formula. First off, we have the opposite of b, so negative 1, plus or minus the square root of b squared, so 1 squared, minus 4 times a times c, all over 2a. So I'll do a little simplification. So I get the cosine of x is equal to negative 1 plus or minus the square root of, let's see, we've got 1, and this becomes plus 8, so this is 9 over 4. Alright, square root of 9 is 3, so we've got cosine x equals negative 1 plus or minus 3 over 4. And so now we have negative 1 plus 3 is 2, so 2 over 4 is 1/2. And the other possibility is negative 1 minus 3 is negative 4 over 4 is negative 1. So the cosine of x equals those two possibilities. Alright, so let's figure out what those are. Now principal values, as I was saying, for cosine, that's going to be between 0 and 180 degrees. So where does that equal 1/2? Well, for cosine x equals 1/2, that's going to be where x is equal to 60 degrees. And then for the cosine x equals negative 1, that's going to happen at 180 degrees. So x equals 180 degrees. Okay, so there are my two possibilities. Great. Let's keep moving on. The next one, we are going to look at the solutions in the entire unit circle. So all the way around we have possibilities. We're not limiting ourselves to the principal values. We have the whole unit circle from 0 to 360 as our possibilities. The other interesting thing for this problem is that we have this double angle happening in here. And this problem, it would be really tempting to go ahead and apply a double angle formula. Okay? And that would be okay, and we'd go through it, but I think that that would actually make things more difficult. Okay? In the unit circle, let's ignore this 2x for a moment, and let's just think about the sine of theta. And think about where does it equal root 3 over 2. Now, in the unit circle, that would happen when theta is, what, 60 degrees? And also at 120 degrees. So now what this tells me, though, is that 2x is my theta, so it's 2x that has to equal 60, and or 2x equals 120. So now I've got x equals 30 degrees or 60 degrees from the other one. And that's an easier case to solve. If we don't have to make it difficult, let's not. Okay? So there's a tip for you. Number 4, we are going to look at a half angle identity to solve this one. And to do that, hold on a second, the loud fan just turned on in here. So to solve this with a half angle identity, I have to think 67.5 is half of what? Okay? Half of, well, double 67.5, that takes me up to, boy, 135 degrees. Okay. So the problem we're actually going to solve here is that the cosine of 67.5 can be thought of as 135, over 2. Okay, so we apply our half angle formula to that. We get plus or minus the square root of 1. Now it says plus cosine of 135 all over 2. I use this u value right here. This is the value that goes in for the function. Okay, we'll deal with that plus or minus later, alright? So cranking through that, we can go to our unit circle. We get a little bit of clarification on what the cosine of 135 is. So let's take this cosine of 135 over 2, positive or negative, square root of 1 plus, and on the unit circle it says 135 is going to be a negative root 2 over 2 all over 2. And I am perfectly fine with you leaving it as this under the radical and not simplifying it. However, we do need to decide, is this going to be positive or negative? And in order to do that, I refer back to the original angle, and I have to think what quadrant that's in. This is in quadrant 1, and as we've discussed in class, that means all are positive there. So I'm going to choose the positive version for my final answer. So the final answer is that the cosine of 67.5 is equal to the positive square root of 1 plus a negative root 2 over 2 all over 2. And some of you are asking, well, could I just write this as 1 minus, and that would be okay. All right, and there are some more simplification steps you can take, but I'm not going to make you do that. All right, last one here is a multi-part problem, okay? And this one, I'm giving you a piece of information. I'm telling you what the cosine of the angle is, and I want you to find the cosine of twice the angle. And the intent here is to apply the double angle formula. All right. Now I'm giving you the cosine, and we have multiple choices for the double angle formula. There are 3 choices for this particular double angle. I'm going to choose the one that only uses cosine because I'm given the cosine. That makes the process simpler. So I'm going to use the one that says cosine of 2 theta is equal to twice cosine squared of theta minus 1. That way I can just plug and chug. I take this value and plug it in for the cosine. So this becomes cosine 2 theta is equal to twice the square root of 3 over 2 quantity squared minus 1. So that gives me cosine 2 theta is equal to twice. Now I'm going to square this. So the square root of 3 squared is 3. 2 squared is 4 minus 1. You can pop that in your calculator and you get cosine 2 theta is equal to 6/8 minus 1 is a negative 2/8. Just try that in your calculator. The calculator will actually simplify that a little bit further. Oh my goodness, I make a little bit of an arithmetic error there. Let me back that up. This isn't 6/8, this is 6/4. Sorry about that. So 6, that's going to give us a different answer here. Sorry, 6/4. I guess I should have used a calculator. That's going to end up giving us 2/4 or 1/2 for our final answer. Okay. Now this problem could be easily changed. Hint, hint. If I was to give you, say, the sine of the angle, I would choose the value for the cosine double angle formula that only uses the sine. If I gave you both cosine and sine, I would choose the one that uses both cosine and sine. Use the formulas that fit the information you're given to make your life a little bit easier so we don't have to go digging for stuff. I hope this helps. Good luck, and we'll see you in class.